Okay, I am back with another one of my Watch Brian Learn Live online streaming series for YouTube. This time I've got Ryan Levick with me, and he's going to drag me into the modern era with Rust. We are hoping to do a project today learning some command line programming in Rust. So Ryan, would you introduce yourself really quick and kind of give us an idea of where we're going to go today with this command line app?
Yeah, cool. Hi, I'm Ryan. I've been doing Rust for quite a while now, and it's what I do full time for my job. I'm very excited to be talking with Brian today about it and showing him some code. The idea for today is really just to get started in Rust, to learn a little bit about it. And the way we're going to do that is by building a small command line utility that allows you basically to store values based on keys, so a small key value store that basically dumps key values inside of a file, and you can write to that file and read out the key value pairs from that file. And hopefully we can do that in a relatively short amount of time, and that should get us pretty far into learning what Rust is all about.
Okay, I got a note from someone on YouTube that we had some echo, so I just changed a little bit on the speakers. Let me see if that helped. Hate to have ugly echo, that's so distracting. Someone could let us know if we still have nasty echo, we'd appreciate it. Not yet. Okay. I'll click more buttons. Let's try that. Nope. Okay, how about now? Any echo? Saying things, yeah, it doesn't make any sense, does it? Not talking. Ryan, can you talk to a little bit? Make sure that the echo.
Yep, hello. Test 1 2 1 2. Hopefully everybody can hear.
I think we've got a good 20 or 30 second delay.
Still echo.
Still echo.
Echo from Ryan. Okay.
Just Ryan?
Is it just from me? And apparently it's not echoing for everybody, strangely.
Not for everybody. I don't know how to fix not for everybody. All right. No echo from Miguel. Echo from Ryan. We still have my audio, yes. Say something again, Ryan.
Hello, hello. Is this echoing? Hopefully not.
Just from Ryan. Why just from Ryan? Okay. Turn that off. Hello, hello, hello.
And hello, hello, hello.
Some people not have any echo at all. That's really strange.
Just refreshing seems fine.
Okay. All right, well, let's roll with it because we can waste all day playing with audio.
Yeah.
Trust me, I've done it. All right, so you were going to introduce yourself and talk about where we're going, what we're going to do.
Yeah. So just to repeat again, yeah, I'm Ryan. I've been doing Rust for quite a while now, and I do it for my day job as well. And I'm very excited to be with Brian today to help him learn a little bit about Rust. So the thing that we're going to be doing is we're going to be building a key value store, command line utility, where you'll be able to write key values into a little database that's stored on disk, and then read values based on keys from that database. And so hopefully with that, as long as the audio issues are doing okay, we can get started.
Let's do it. So I started off, I jumped the gun, and I hit cargo new -- bin and created a new cargo project on the command line. And I also put it up on GitHub. It's at bkettlesonkv. It's completely empty with just a README and a license file. So this is almost exactly what cargo new outputs. And I'll put that maybe in a comment at the top of our code file here. Can I put comments anywhere in Rust? Does it matter?
Yeah, you can put it anywhere.
Okay. Oh, look at that Rust format go. Love it. Okay. So let's get started. We've got the idea is that we're going to do something like kv add some key name, some value. So we need to be able to interact with command line parameters. Is there an easy way to do that in Rust? Are there some nice parameter parsing tools?
Yeah, there's some really nice parameter parsing tools. Just for everybody's reference, the thing that you would do this if you wanted to do it without a library is to just read in from standard args, and you can kind of take whatever you need from that. But a great tool for that is something called struct opt, which allows you to declaratively say what your command line arguments look like, and then you can. Then it will basically generate the code that allows you to read those values. And then, so sending to Brian now the GitHub page for that.
Okay, I have the docs.rs up on the screen for it, I think. Chat. I think that's it.
Yeah,
it looks like
that should be it.
So to add a new dependency, we just add it directly to our cargo.toml file, just under dependencies?
Yep, yeah.
And
so you can just add struct opt.
Like cargo.add?
I believe there is a way to do it from the command line, but the way that I do it is just pasting it manually into
okay. All right. So
into the cargo.toml file.
Added. And then in our main, we have to import use struct off. I'm just going to copy these use statements. Now, is use the way I've seen things that look like use in previous languages before, like using, it takes the namespace of those modules and adds them to your current namespace so you can access methods, functions, exported things inside your current module without explicitly typing the whole module name. Is that the way use works in Rust?
Yeah, so for Rust, it is you're adding when you say use, you're adding it into your namespace. So there are some languages where it adds it adds an entire namespace into your namespace. But here, if you say use standard pathbuff, you can now use pathbuff. It doesn't add a pathbuff module into it. So use standard pathbuff just gives you access to use that pathbuff struct now.
So it's making it available for us. It's not introducing it into my module scope.
It is introducing pathbuff into scope, so you can use pathbuff now. Yes.
Okay.
There are some languages like C# where use kind of brings in an entire namespace. That's not how Rust works.
I didn't know how to say that right, but yeah, we're on the same page here.
Okay.
Good. And RLS works. Yay for language servers. Big shout out to SourceGraph and everybody else who made language servers happen.
Yay. So from the README of struct opt, you can see they're declaring this struct called opt, and they define in there what the different arguments that they want to take here, what they want to take are. And for us, it would just be probably add and get or fetch or whatever we want to call it.
Okay.
So we can kind of just use that as a little template then. So the opt they have there, you can imagine now there's going to be like a debug, a verbose, a speed, an output option, and stuff like that. We only want two, presumably, maybe with a third one for being like help or something like that. But it should come with help automatically. I believe that's generated for you.
All right, so pathbuff is a file name, I'm assuming. What will we do for just like a string? Is that like this level one where we have a vec?
Yeah, you can just do string instead of vec string or something like that.
Okay.
That should work.
So we'll call this one command, or what would our subcommand?
Well, most likely, I mean, whatever the name you provide there is the name that it's going to be at the command line. So you, do add or something like that.
So when I type that on the command line, is it going to be kv --add like that?
It would be --add if you provide actually right now, yeah, it would be --add.
All right.
So
how do we get it to look like a subcommand sort of thing?
Let me see here. That is, I believe if we want to have a subcommand, then we add like a substruct. And maybe you were right before with going with just subcommand, calling it subcommand there.
Well, it's still going to look for something with dashes in it, I think.
It should, if you do something like sub command and then, or we can just call it command like this. And then we can define down here a command and say add or get and something like that. This should work.
Okay.
And I believe if we don't annotate it, then it won't have any of the like dash or dash syntax to it.
So let's get rid of those. It doesn't like.
And then, sorry, it's been a hot minute since I've done a subcommand like this without using dash.
It's all good.
I believe we'll have to say that it's a struct opt thing like this, and then for doing it on this, then we have to annotate the.
Here, struct opt name equals.
Yeah, that would be setting what the name would be when you do dash. and we have to make it.
To see my code with just a sea of underlined red squiggles.
Yeah, it's just saying here, like before it was saying command doesn't implement debug. So we've gone ahead and implemented debug there.
Nums are not supported. Why is it a tuple?
Why is what not a? Why is what a tuple?
Struct up tuple enums are not supported. This is on line 13.
We should be able to say like we have to kind of fill it in with what actually get and add are, and let's just do one for now, so we don't have to define the whole thing at once. Not sure why it's saying that it doesn't define debug when it does. Before we, maybe instead of getting lost in the actual like how to make it not dash dash, we could just start with dash dash real quick, since that's
fine with me.
What the examples are showing real quick. Exit. So we can just do this. We can just say this is going to be add. And add is going to take
String.
a string.
Has to be two strings then. Or no, we can do a value key.
Yeah.
Simplifies a lot.
Yeah. So
need this. Or did I do that wrong? There.
yeah, for now we can just call this key.
Then how about an operation? We have a key, a value. And value should be optional. We can let's just set for now. We'll start small. We're only going to set. Okay.
Do you want? So what would you like to do? You want to? How would you like it to look like?
Well, how I would like it to look would be kv subcommand. No, set or get, and then key, and then optionally value for the set.
Yeah, okay. So then we want to have something called subcommand, and that's just going to be our subcommand enum, which will just be either set or get. Just like that, and that will tell us exactly what we're doing there. We don't want any of this at all. The RLS seems totally borked for some reason here. I think that's our issue. We're getting very strange errors.
All right, let me try building it. Oop. Unused import. All right, so it needs parentheses after struct op on line 9.
Okay.
And we haven't used path buff. So
Yeah, that's fine. I mean, we probably won't use that.
okay.
We can just get rid of it.
Now it says subcommand does not implement from string, the trait from string. So in our enum here, do we have to do something to implement from
string?
Yeah.
Yeah. We just have to tell it. We have to tell it how on the command line how it should take a string and turn it into this enum, because it doesn't know how to go from a string into our enum.
So we need that parse from OS string, like they have in the docs. I'm just going to copy and paste that. Like struct up. Too many parentheses now. Where does from OS string come from?
And from OS string should be in the standard library. So.
Oh goodness, hang on. All right, the trait subcommand from string is not satisfied. The trait bound standard string standard convert from is not satisfied. The trait standard convert is not implemented for standard string. But following implementations were found.
I wish I could see what you're seeing.
Oh, you can just type cargo build. In fact, you can open the terminal, hit control backtick, and you can see my terminal. It's shared. Can you see the terminal?
No, I can't.
Okay.
Unfortunately.
You're typing.
I see problems up.
Yeah, hit type cargo build. It's a shared terminal. You should be able to.
Yeah. So it's saying the first one is saying command does not implement standard string from string, and this is standard string from string is a trait that says how do I go from a string to the type that implements this thing.
Right.
And so if you go and look up standard string from string in the standard library documentation, you'll see that we have to, first we have to import it up top. And then what we'll have to do is actually implement it for our type. So implement from string for subcommand, like that. And it expects us to basically implement this function called from string that takes in a string and returns a result. So this is the first thing. It's going to take in some kind of string slice, and we have to say to either return back a parsed thing or an error of some sort. And I mean, the type of, we have to provide what type of error that we're going to return, and it's going to be, I don't know, we can just return a string as an error. So we have to look at the string and say, we can say, okay, if S is set, then we return back, okay, subcommand set. Does this make sense? We're just
so far,
looking at the string.
The okay, is that a macro?
No, okay is just so okay result here. Result right here is just an enum, and result is either okay, like everything is good, okay, success, or error, ERR, which is an error.
All right.
So the result, there are no exceptions in Rust, for instance. Usually how you handle errors is through this result type. And when you have when everything is fine, you'll return OK in the thing that you want to return. And when there's an error, you just wrap your error in this error type. And so on the next line, you're just going to say, OK, when it's anything else, when it's not set or get, it's anything else, we're just going to return an error here. And the error will be, must be sub command must be either get, or set, like that. And that should take care of that. Now we have to let it rebuild, and still not, my RLS is still not working properly for some reason.
All right, so now we have 3 errors. We still haven't satisfied the from, and we still haven't satisfied the from, and mismatched types. Error, expected struct, standard string, found a reference. Try using conversion method dot to string.
So this is a really good point to talk about something funny with Rust. Rust is a systems level programming language, right? It's going to care about certain things that in other languages you don't have to care about because it's meant to be a low level language. And one of them is strings. Strings are actually quite complicated, and high level languages like JavaScript, for instance, there's a lot abstracted away by the runtime from you. But in Rust, we don't have that luxury because we have to have a lot of control over the machine. And so string literals, like the one that we set up there, where subcommand must be either get or set, are literally embedded in the binary that you're working with. And so we're just taking a reference to that embedded data in the binary. So that's why it's saying it's an ampersand str. It's what's called a string slice. We're simply looking at memory somewhere else. When we call .toString, it might be a bit weird coming from another language, like it already is a string and you're calling .toString on it. Well, we're going from a string slice to what's called an owned string, a string that we have ownership over the memory. We can move that memory around. It's not embedded in our binary. We can actually own that memory. Does that make sense at all? Mm-hmm. That's part of the ownership model, and we won't get a ton into it today, but that's very important to get an understanding of when working with Rust.
Goodness, I've been doing the Pony stream with Sean Allen because their concept of reference capabilities is very similar to this. So I've had a lot of preparation for this kind of thinking.
Awesome. Are we still getting the error? Like I still see the old errors for some reason.
No, I
so
just
I'm not seeing
build and it worked fine.
Awesome. So if you run the thing, I don't know why I'm not seeing any terminal output, but if you run it and try and get help, like -- help, does it show you?
It just says hello world because we don't have anything in main telling
of course.
us
Yes.
to
of course.
opt from args. So let me go do that.
Yeah, we have to go ahead and actually parse the arguments.
Hey. All right, nice.
Cool. So we finally got something going, which means we can start working with it. So unfortunately, I'm a little bit behind because I can't see what it looks like. But now we basically have our opt struct. So it's taken the command line arguments and converted it into this opt struct. Now we can look at it and do things with it. So presumably, the first thing we're going to want to do is look at the subcommand and decide, based on that subcommand, which path to go down to, whether we do get or set, right?
Yep.
And I mean, the best way to do that most likely is through match statements. So I'm going to try and refrain from typing and let you type away.
Yay.
But it's going be very similar to what we're doing inside of the from_str method up top.
How do I get fields of my struct, my op struct? Do I do op
Just,
dot?
Yep, op dot. Yeah.
Dot subcommand?
And it's lowercase, not unlike Go with lowercase s, yeah.
And the subcommand that is stored is actual subcommand type. So I'm going to want subcommand get that. Just copying your syntax over here.
Yep.
And we're going to do
one great thing to do is you can use the unimplemented macro, which is just unimplemented bang open close parentheses. And basically what that tells the compiler is make sure this compiles, and if code actually reaches here, panic and crash the program. So it's a good way to, if you're working on something like this, just throw in an unimplemented and it says, okay, the code will compile, but it will, will crash at runtime. But it's a good way to kind of start, getting things in place.
I feel like
that looks great.
That's a direct hit against Go with the unimplemented bits in Go's. Go compiler won't let you continue in any way if you've got unimplemented things. All right, so let's try this. Get. Nice. Required arguments. You sure you can't see my terminal?
Yeah, I'm on the terminal screen and it's blank. So
if you go to the live share window, the live share tab in VS Code, can you double click on the shared bash terminal? Does that get shown?
Yeah. I'm double clicking on it and I can't see anything, unfortunately.
Wow,
I don't know what's up.
It's taking your input though.
Really?
Yeah, you just
don't
clicked
see
ls and it definitely showed up on my screen. Echo hello.
I can't see that, but
that's a
cool.
shame. I'm sorry to hear that.
Yeah. No, that's all right. We'll make it through it.
Okay, so I just ran kv get, and it said the following required arguments were not provided, key and value. So that's actually pretty awesome. Get, I'll do -- key, Ryan, -- value, hello. And thread main panicked with not yet implemented. Yay!
Yay! Cool.
We rock. Okay. So we can make some, like a save function. Do we need to define what our data storage looks like? Are we going to have a
yeah, that's a good question. Yeah, we can store all this in a file as just and separate it by new lines. It's kind of the world is our oyster, really. Whatever we want to do.
Well, I say we keep it in maybe it's not the most optimum way to do it, but let's keep it in some sort of vector or map, or a map with keys. What does Rust have for mappy things?
The only issue with that is we're going to be running this. We're going to be starting the program for get or for set, and then when we want to get, we're going to run the program again. So anything we keep in memory will just go away, right?
Yes, but I was thinking that we were going to serialize it and write it out to JSON to a file.
Okay.
I've got
we can do
big
that.
dreams.
Cool. Yeah, that sounds good. So yeah, the standard map for that is in standard collections hash map. So standard : collections : hash map. And it works how you would expect it to. It's generic on key and value. So presumably we're going to, when we actually use this hash map, it will be a hash map of string to string.
Okay, that makes sense.
And so most likely, I'm guessing in set, what we're going to do is first read it from the file, deserialize it to our hash map, put it into our hash map, and then serialize it back out, right, to disk.
Yeah, but that's a chicken and egg thing, because if we don't have it the first time, we're going to have to...
Yeah, we're going to have to create the file. Yeah.
Why don't we work on the serialization to and from disk
Okay.
and go backwards, because that
Cool.
seems like the smartest thing to do. And then we can add a check to see if the file exists and create it the first time.
Yeah. That sounds good.
All right, so how do we do... So I added this hash map use declaration. How would I do something that looks like a global variable in Rust? Do that.
Why do you want to do a global variable? What are you going to try and accomplish?
Okay, let me rephrase that then. We have a hash map, and I guess we don't need to because we're only doing one operation at a time. That's a really good point. Thank you, Ryan. We don't need global variables. I shall now be quiet.
Yeah, Rust has statics, but generally you don't want to use them. It's usually only in lower level code that you're going to use statics. Most of the time you wouldn't want to do that. So I guess let's go back. What are we going to do? We're first going to deserialize from a file that we assume exists, right?
Yes, and if it doesn't, we'll create it. So let's start with function load. Is it idiomatic to use underscores or camel case?
Underscores.
Load keys, and that needs to return some sort of error. How does that?
Yeah, so we're doing I/O in this load keys function, right? So the most idiomatic thing to do would be to return an I/O error, standard I/O error. Standard I/O result. Sorry, it's not a fat rocket like you put there. Skinny arrow. Yeah.
Like that?
Yep.
Okay.
And result. And all that standard I/O result is just like a regular result that we've seen before, but the error is hard-coded to be I/O error, which is the standard kind of I/O error type things that you have, like, not found and, whatever you would expect from I/O. So we have to, in standard I/O result, say what we expect to return from this thing. So it will be a result, but a result of what? And I'm guessing it will be that hash map, right?
Yes, so that's going to be standard.
And we already have hash map in scope, so we don't have to do standard collections anymore, right? And hash map is going to be generic. And just as I was saying before, we don't have to provide the error here, because standard I/O result is just the type alias to result of some type T, and the error is hard-coded as I/O error. So it's easier if I write this out. When in the standard library, I/O result is basically defined like this. I/O result of T equals result, which is just a global result of T and I/O error.
Gotcha. Okay.
So that's what you would find in the standard library. So the hash map itself is going to be generic on a key and a value, right?
Yeah.
And so we have to say what types those keys and values are. And I imagine we're just going to do string to string, and string is available globally, so you don't have to do standard. It's another way of saying it's available globally is it is part of the prelude, the standard library of prelude, and those are the types that are just, you don't have to import explicitly, and those are common things like string, vec, result, stuff like that. Cool.
It doesn't like the
So
syntax with the brackets on the hash map declaration. Did I do that wrong? KVS. Random state.
I can't see the error.
It
Sorry.
says, it doesn't say. Let me try building it. Rust is the most helpful compiler ever. Implicitly returns empty parentheses as its body has no tail or return expression.
Yeah. So think about what that's saying. It implicitly returns, and the empty tuple is called unit. So it's saying your function is implicitly returning unit, but it says that it should return a result of hash map, which is true, right? We are not returning anything from load keys right now. So it's saying, hey,
Gotcha.
This function should return a result, but it's returning nothing. So good. We could go back to our old friend unimplemented in this case, just to get things compiling again, to say our load key function is not actually implemented yet.
Okay. Born dead code. I love it. Okay.
Cool. So now we can start to think about how we actually implement this thing. Presumably we want to read from a file, right?
Yep.
So that is available at standard FS file that we can get to, std FS file.
Do I need to use standard FS?
So using is always unnecessary. It's only how you want to refer to file. Do you want to just write file?
Gotcha.
Or do you want to write standard FS file every single time? If you don't want to write standard FS file every single time, then you can put use up top, and that means you can refer to file without its, without the namespace. But if we're going to use it only once, you can, it's kind of up to your personal preference. And most likely what we want to do is call open on it. So, and the reason I know that there is an open method is because, there's the docs, and I went to doc.rustline.org and looked up file, and the first one is a file called open.
I'm going to go there too. Hang on. Standard modules. All right, how do I get back? FS. Functions. File.
The best thing to do when you're looking for something, I tend to do is up at the very top of it, there is the search function. So you can just search for file, and it will show you a bunch of, things in the.
Okay.
Cool. So we're opening up the file now, and I think it's because you copy pasted. You have the question mark there. Maybe we should explain what the question mark actually does, because question mark doesn't exist in Go. It does recently exist in JavaScript, and there are languages like Swift, for instance, that have this. It works a little bit differently in Rust. In Rust, what the question mark does is it takes a result, and let me just write it out real quick to what it desugars to. So you're calling this file open here, and the question mark basically adds a match statement and says, okay, if it's there, if it's okay, you can return back the thing, and if it's an error of some sort, then return the error from the function, basically.
Okay.
So it's reaching into the result, getting out the thing that's if it's okay, and if it's not okay, returning an error from the function. So that this is basically a quick way to say, if it fails, just bail out of the function. I want you to propagate it up. It's kind of like a
delightful syntax.
It's a throw basically, like, but it doesn't unwind the stack all the way up until there's a catch. It just throws it up to the next function, and the next function has to handle it. And maybe that next function also has a question mark, so it'll throw it up. So it's kind of like manually unwinding the stack, but it's a very short syntax, so you don't have to. So it's quite easy to use, but you don't have to. It's never ambiguous about when will this error be caught? It will always be handled in the calling function. That calling function may also propagate the error, but it's always going to be at least explicitly handled. There's no magic like you have with exceptions.
Mm-hmm. That's delightful. I like it a lot.
Cool. So we called open, and that the file variable now has a file handle, right?
Yep.
On it.
Now we need to read the bytes.
Yeah, so we want to go ahead and call some kind of read on it. And the best thing for us to do, I think, would be so file implements this trait called read, which is just a whole bunch of like reading things where it can read data. And one of them is read to string. I think that's probably what we want. We want to read this, read into string here. And basically what it does is it reads everything until it finds an end of file thing in your file. And so on file, we're going to want to call, read to string, and we have to pass in a buffer. So we're going to have to pass in the string to actually read into. Great, contents, exactly. And we can just say, equals string : new.
Okay, hang on a second. I'm getting paged. Okay, so let's see, mute contents. What do I want this to be? A string?
Yeah, you want it to be a string. This is going to be our. You have to initialize it. So everything in Rust is always initialized. You never have uninitialized variables ever. That is totally not a thing. So you want to do let mute contents equals string : new. And this is just initializing a string on the stack here, and for your read to string function, you're going to pass the contents in as a mutable reference. So you want to do : mute contents. Sorry, not colon.
Ampersand.
Ampersand. Sorry, not Englishing today. And unfortunately, Rust is not like Swift, so you can't do the buff : you just pass it in without the buff : There's no named arguments in Rust, which is a little bit sad in my opinion, but maybe in the future. Great. So we have a buffer called contents. We're reading our file into that buffer, and now after line 48, the contents contains the value of our file inside of it as a string, which is awesome. Exactly what we wanted.
This doesn't build though. It says no method name read to string found for type standard FS file in the current scope.
So most likely it's saying below that another error or another helpful hint, I would imagine. I can't see it right now, but I would
trait is
think it
but
will.
Not in scope. Perhaps add a use for standard IO read.
Well, there you go. Thank you, Rust compiler. We shall do that. So
once again, compiler errors for the win.
Yeah.
Okay.
So what that's saying is that read to string is a trait method. It comes to file not because we implemented it directly on file, but because file implements this read trait, which is, traits are just interfaces, and read to string comes along for the ride with that. But methods from interfaces are only in scope when that trait is itself in scope. So we have to bring the trait into scope, and that puts the methods from that trait onto things that actually implement that trait.
Yeah.
So with that, it's now
with these compiler errors, though. My goodness, they're awesome.
Yeah, it's quite nice.
All
Great.
right, so now we've got read to string, and I added the question mark at the end because the compiler told me that that this result could be an error and I should handle that. So I made the question mark.
Yes.
So we did handle it. So content should be populated, right?
Yep. And it's good to think about what types of errors could be possible there, right? Like reading strings in Rust are always UTF-8. And so if your file is just a binary blob or something that's not actually UTF-8, that thing will blow up. And so here we're saying, okay, we assume that it's UTF-8, and if it's not, we'll bubble up the error so that the caller of load keys can deal with, we read a file that wasn't UTF-8. But we're in this function, we're not going to deal with that possibility. Okay, so now I guess we have contents as a string. We're going to want to deserialize that as a hash map, right? Or as JSON, presumably.
And I'm assuming we have to use, I don't know how to say it, Serda?
Yeah. So it's how we actually say the name of that. I say Serde, but I think it stands for serialize, deserialize. So ser, and D, I don't know, but I've heard all variants. But yes, Serde is what we want. And this is just a really great library for reading JSON, or actually for reading anything. And so we're going to want to add that and Serde is a general serialization and deserialization library. So if you want to serialize YAML or JSON or XML or whatever, you can use Serde. And then there's a Serde JSON, which works on top of Serde as the JSON implementation.
Oh, so I should use the JSON version.
Yeah, I think we're going to need both Serde and Serde JSON. We'll need Serde to say, hey, our structs are actually, we may not need it because the hash maps, I believe, should just already be deserializable built in. But if we had a custom struct that we wanted to deserialize from, or serialize to, or whatever, then we would need regular Serde. But of course, the compiler will let us know if we do something wrong, which is good.
It's a beautiful thing. All right, so we need to use that.
And then,
right off of the example page.
And so now I guess we can go ahead and serialize our contents buffer to JSON. Yep, there you go. Cool.
We want this to be contents. Expected ampersand string. So, can I do that? I can.
And I'm mad.
Completely new to me, so I just added asterisks and ampersands to everything until things compiled, and I was really happy.
I don't know if does it make sense for us to talk about why you need an ampersand there, or should we just leave that for another time?
I think theory is always a good thing. I'm afraid.
So from Serde JSON from str takes in an ampersand stir. It takes in a string slice. So in other words, it takes in a view of a string, not the string itself. And so if we were to just pass in contents, contents is string with a capital S, not a str. Contents is a string that we own. We own the memory. It belongs to us. But JSON from stir doesn't want the memory. It doesn't want to own our memory. It just wants to look at it. Just wants to take a peek at it. And this is very important in systems programming. Everybody has to know who owns what piece of memory, because at the end of the day, somebody is responsible for freeing that memory. If we didn't have that, we would have bugs like you have in C or C++, like double free, use after free, because in C, nobody is quite sure who owns what memory. Nobody's quite sure who is in charge of actually freeing that memory. It's totally up to the programmer to like arbitrarily decide that. And if the programmer gets it wrong, you end up with bugs. But Rust takes care of that for you. It has this ownership model. And so contents on line 49 is our string. We own it. And when it goes out of scope on line 53, it will be freed. Its memory will be freed. And on line 51, when we pass in ampersand contents, we're saying here is just like a way to look at our memory, but you don't own it. Like I'm lending it to you. That's what the ampersand says. I'm lending it to you, but you don't own it. I still own it, and I'm in charge of freeing that memory when it's done, when I'm done with it. Does that make sense at a high level?
And it seems really important.
Yeah, because we don't have a garbage collector. We are completely free of a garbage collector here. So like if we don't do it, if we don't put this in place, nobody will, because we don't have a garbage collector to do it for us. And that's why in other languages, you don't have to care about this stuff, because the garbage collector just sometime in the future will free this memory for you. But we're a systems programming language, so unfortunately. Yeah.
All right, when we added...
Not to make mistakes, it won't compile.
I'm sorry. When we added Deserialize to the top for the use, we broke line 28, the from string. This self error seems to be pointing to the wrong thing now. Now the compiler says wrong number of arguments, expected 1, found 2. And when I hover over it, it says mismatched types, expected struct, Deserialize, error. So I think this error, maybe I shouldn't be using something. What is this? I think
so
we have too many errors in our namespace.
I wish I could see what you were pointing at.
So on line 28, where it returns result self and then self : error, error. The RLS says wrong number of arguments, expected 1, found 2, unexpected type argument. And then on the line 32, where we return ERR, it says expected struct Deserialize : error, found struct string. So I feel like this error on line 32 is not the same error that it used to be.
Yeah, that is quite strange. What do you have up top? Like,
I added use Deserialize result value. I can remove that.
Where? Can you show it to me?
On line 2.
Yeah. So you brought in a result type that is now clashing with the result that's already in the standard library.
Gotcha. So can I just get rid of this use?
Yeah. I think we need value, the value thing, because of line 51.
Okay.
But we do not want result. We already have a result. We're taking care of it. Get rid of the result portion.
And I don't need the brackets anymore then if I do. Why is my keyboard not working?
If you save it, Rust format will get rid of it for you.
Rust format. Okay, now type annotation required on line 51. it says cannot resolve something as standard ops try OK.
Yeah, so what you've done is you've unwrapped the error that you get from stir. That means if it's an error, panic, abort the entire program. But you don't want to do that, right? You want to do question mark, try and propagate that up, and you might get another error. You might get another compiler error now.
Consider prefixing with an underscore. Unused variable v. Okay.
Yeah.
We will use.
Is that all it says?
That's
awesome.
Yeah.
Cool. That's great. Then we're done. So.
All right. So now we've got this value, which is any valid JSON value. Can we just dump it to standard out, standard error?
Yeah, we should be able to just print it.
Print?
A print line, or print ln, sorry. Bang.
The macro version?
Yeah, it's a macro. And then it's going to take a string literal that when you want to interpolate something, it has, exactly like that. And so you could just pass v. And it should just, you could just pass v. And then don't forget your semicolon at the end there.
All right, so let's see if that compiles. And if it does, then we should be able to call load keys from main, and it should give us an error because it doesn't exist.
Yeah, so maybe we just create it real quick.
I don't mind seeing what the error looks like.
Okay.
Now this can return some stuff. So I need a question mark, and I need my hash map. So let values, no, let map, colon, where's that hash map thing again? That's standard collections hash map, and I'm using it so I can just type hash map.
Yeah. And you also don't need it because it will infer it for you. But I mean, if you want to, it's totally fine to do as well. You can do what you've done.
Let map equals?
Yeah, let map equals, exactly. And it will just infer based on load keys. Now, there's one issue. Maybe go ahead and try and compile now, and you'll see that it won't compile.
Oop. Right. Well, the first error I got is unreachable statement, because we can never get to load keys because everything else is unimplemented and they're going to panic.
Yeah.
Question mark operator can only be used in a function that returns result or option.
Mm-hmm.
And we're
so our main function doesn't return a result, but it can.
Oh, we don't need it to. That's fine. All right.
So we either we have to handle our error somehow. So we can match on it, or we can panic if we get an error. Like, what should we do if load keys fails? What do we want to happen?
I don't know. Let's for now, let's panic. But then step 2, we should call a function that creates it.
Okay. So we can go ahead and just call .unwrap on load keys, and that will, if it finds an error, it will panic with that error. It will abort the program and say, there was an error, and it will print out the error that it got.
Okay.
And unwrap is really great for like early prototyping and getting things working, because you don't really want to handle errors at first. And then once your program gets a bit more mature and you want to start hardening it and making it a bit more resilient, then you can start handling those errors by not doing unwrap. So unwrap is good until it's not good, because you don't want it to just crash.
Beautiful. All right, so I compiled it and ran it with the same command line options I had before, which was what? I don't remember what it was. Oh, get --key Brian --value hello, and it printed my opt to the screen, which we expected, and that all looks good. And then it panicked at called result unwrap on error value, and the value is OS code 2 kind not found message no such file or directory, which is what we expected because it didn't exist. So how do we trap that?
The best thing to do is, so instead of calling unwrap, we would match on the result that we get back from load keys to do a match statement.
So we do match like this.
So I'm going to stop us right here because most likely this is not what we want to do actually, right? If we call load keys, catch the error that we haven't found the file, and then we have a valid file, but we want to call like the rest of load keys with that file. So we probably want to catch the error inside of load keys, not outside of it, right?
Okay.
That would make more sense in my opinion.
You're absolutely right.
So we probably want to go ahead and do the match on line 51 inside of load keys and say match file open, and then look at the actual error that we're getting.
All right. So here we're going to get rid of the question mark.
Yeah.
Okay. And then match. Do I do match?
Yeah, match after the equals sign. So let file equals match, standard FS file open. And then before the parentheses now, or before the semicolon, do the curly braces, dance. And then the first one is okay. If the file opens, okay, you're going to get a file inside of there, and you can just do rocket, fat arrow, whatever you would call it, file, and instead of semicolon, it's a comma. And so that's what we had before. That's great. And now we want to match on error, or ERR. And then we want to match against the type of error that we're getting. And so let's see here. Think what the type of error that we get inside of ERR. So ERR is just like, okay, it contains something inside of it.
Yeah.
Contains the error. And what we want to do is look at that error and see what kind of error it is. And so you're going to have something like, error like this. And what we can do is say, if we have this error, if that error's kind, the kind of error it is, equals, and then I believe error kind is standard IO error kind, and there should be not found. Yeah. Like that. This means the file wasn't found, and now we can handle in here the file wasn't found, right? And then if there's any kind of other error, we just return, well, you can say return that error. Like that. Does that all make sense?
Yep. And this
so now
match arms have incompatible types.
Yep.
Expect
because we're not actually returning a file when there is a not found error, so we need to create a file inside of there.
Okay.
By the way, this isn't how you would actually do it in Rust, because there's an option you can pass to open that just creates the file if it's not there. But I didn't want to do that because this is more interesting code. But just in case you're actually wanting to write this in the future, there's a way to call open and have it create the file when, if it doesn't find the file. But this is good practice.
It is good practice, actually. Okay, so now we need to create a file.
Yeah, so we would call standard FS file create and give it the same path that we gave before, kv.db. And we want to put a question mark at the end here because if there's an error when creating the file, we'll just propagate that up to the caller. Like, we don't really want to handle anything going wrong with create in this particular thing. So that should do it. Now we have a file, and if it's not there, we create the file.
Wait, why did it changed this?
What did it change?
It changed that.
No, I changed that before.
Oh, you did?
Because we want to return. Yeah, if it's an error, we return that error, right? The underscore would just be anything else, but we don't have any way to like refer to what that thing is. But we actually want to take the value and return it back out.
Like that?
No, like it was before. E return E, because we want to return the error wrapped in the result error variant, right?
Yeah, cargo build does not like that because it expected a hash map, but we found a file. So do we need to unwrap something somewhere, or?
Probably because it's
we're returning a hash map.
So go back to what you were doing before with the error E.
Yep. This.
And ERR parentheses E.
Yep.
And then in the return there, go ahead and wrap that in an ERR again. Does that work?
Yep.
So we're just like, it's because before we're taking a different result type, the result we got from file open, and trying to return it as our result of hash map. It's a little type difference there. So we're just taking the error inside of and rewrapping it in our new error, basically.
On line 53, don't we need to assign the result of this to file?
That's what's happening. So match expressions they're not statements. The term match statement does not exist in Rust. It's match expression. Matches return whatever value they resolve to. And so on line 52, the file there will get returned back into the file assignment at line 51, and the value of create will get returned into will be assigned to file on line 51 as well.
Matching is cool.
So everything in Rust is an expression, unless it explicitly ends in a semicolon. So assignment, for instance, when we're assigning, we end it in a semicolon because it's a statement, not an expression.
Okay. All right. So this builds, and we're creating the file if it doesn't exist, and then we're reading it, and let's try running it and see what happens. All right, so thread main panic not yet implemented on 45, so we actually made it past load keys, and we printed nothing on line 60 because it didn't exist. So
we're getting some kind of error. So we probably want to we probably want to go back to line 42 where we call load keys and still call unwrap so that we panic when there's an error from load keys.
Are you sure we're getting an error?
If we don't get to line 60 where it's printing.
We get to line 45. It's giving us the unimplemented on line 45.
But if we if there wasn't an error inside of load keys, then we would panic on line 61 because there's unimplemented there as well.
Panicked at line, where? What line? Result.unwrap on error value custom kind unexpected EOF. EOF while parsing a value. So we got an EOF here, I guess, when we tried to read from string because our buffer was empty. I'm assuming result unwrap on error value, custom kind unexpected error or parsing the value. That's the only place we're doing that. So this line 59 is blown because our contents is empty.
I mean, while parsing a value, it sounds like because our contents are empty, which makes sense. The file has nothing in it, right?
Yep.
And we're trying to deserialize that empty file as JSON. And like, how would you do that, right?
You can't.
Yeah.
So
the question, what do we want to do there? Like when the file is empty,
can we put an empty JSON struct of some sort, or I don't know. What's the right thing to do here?
We can push an empty JSON thing onto contents if you want.
Yep.
Like if contents dot is empty, and then contents dot push stir, and then an empty JSON object.
Is empty. Returns a true. Do I need brackets here? Like that?
Yep.
If it is empty, then I want to, how do I add stuff to it?
On string, the best thing to do is push _str, which allows you to put, and call it on contents dot push str. And then you provided a string literal with that you want to push onto your contents, and maybe we just do curly bracket, opening, closing curly bracket. Yeah.
Is that a thing that can fail?
No, that should not be able to fail. So you got to end it in a semicolon, but that's it. Yeah.
All right, so I compiled it, and now we run it. And it worked beautifully, and it printed an empty, it printed the two brackets, which is what we would expect. So that's awesome.
Cool. So we've got a JSON value. Now, presumably what we want to do is take that JSON value and turn it into our hash map, right?
Correct.
Somehow.
Yep.
I think, so there's a way to do this directly inside of Serday, but to continue our match practice, I think we should just do that instead, like do it a little bit manually. So there's a way to just do this where Serday will take care of it for you. But that's not as fun. So we'll go ahead and actually match on the value and see if it's a JSON object, then go over the stuff the keys into the hash map, and the values ensure that they're strings, and if they're not strings, return an error or whatever. That gives us more practice with control flow and stuff like that.
Okay. I like doing.
So I think the first thing to do is just match on V and see what kind of value it is.
Here, match V, like so.
And then we want to see is V a value : object?
Like that.
Mm-hmm. And object actually inside of it, just like OK and error contains value. It has an associated value with it, and that associated value is a map.
Hash map, like that, or just
we can just give it a name, so we can destructure it from that, and the hash map that object contains, we're calling it map, and we're taking it out, and now we can do something with it after the error.
So
and
if it's a map,
presumably, yep,
we have a map.
And and map right there is totally arbitrary. We could call it foo or bar or whatever we want to call it, but we're calling it map. So that's fine. And now probably what we want to do is iterate over that map and look at the value that it contains, and assert that that value is a string, get the string out, and if it's not a string, well, then we have a JSON object that's malformed, right? We only expect our database to be JSON objects that are string to string. If it's a JSON object with string to null or string to bool or something like that, that's our database is corrupt, and we should, throw an error or whatever.
Okay.
So the best thing for us to do is probably to loop over our map and get the keys and values out.
I'm all ears.
So the best thing for us to do then, and I'll do it one way, there's definitely different ways that we can do it, is we're first going to create a new hash map. This will be the hash map that we're collecting ourselves into. And I'll call it, I don't know, DB for now. And we're going to create a new hash map. And we're going to look over our hash map at the keys and values. Sorry. I'm having a hard time typing here. Like this. So we're looping over our hash map and getting the keys and values from it.
Okay.
And this is just destructuring. We have, we could call this, real quick, we could call this, why is it not letting me type? There we go. We could call this pair, and we could then get our keys and values out of the pair. But in our for loop, it allows us to directly access key and value because we're going to get them as tuples.
Okay. So then
And then we want to take our, we want to match on our value. And if that value is a value string, then we take our DB and what is it? DB dot set or something like that. And set is just a function on hash map that takes a key and a value and puts it inside of the hash map. So we put in our key and we put in our value like that.
Okay, let's talk really quick about shadowing because we're matching V for our value up on 63, and now we've got another V in 66. How does what are the shadowing rules? Because I remember Rust being different about shadow, like it just lets you can do whatever you want.
Yeah. So you can shadow. So let's be good here and say, okay, this is going to be JSON. And this right here will be our, we'll call this value. And we're matching on that value. And actually, we don't want V here, because V right here is some JSON value. It could be a string, it could be a bool, or whatever. But we just want this. We just want the string, right? So we write in string here. And if our value is not a string, if it's a bool, if it's an object, if it's an array or whatever, we got to do something with it. And I mean, for now, what we can just do is say corrupt database.
Yes.
Wow. Oh gosh, we have a corrupt database. That's not good. We'll handle that more elegantly later on. But now we have a proper hash map that has just string to string in it, and we have that here. So we're going to return that hash map that is filled string to string. And of course, if our entire JSON object wasn't an object, it was something else, we got to do something as well, and we'll panic down here as well and say this is also another case where we have a corrupt database. So does that make sense?
Yep. So we'll say bad map here. And here we'll say not map.
Yep. Awesome.
Good. Now it doesn't like DB set, so what does DB
what does it take? I always forget this hash map. Let me look it up real quick in the docs. Looking. insert. Sorry, it's insert. And insert, if you insert into the DB and there was a value already at that key, it will return that key as well. But we don't care about that. I think we'll just ignore that value.
So this is returning an option now?
Yeah. This right here on line 68 is returning an option because it's returning optionally the value that was already existing at that key. But like, we can ignore it. We can just say, I don't care. We won't do anything with it.
Okay.
So overall, like what we want here is our hash map of string to string. And so really, like, we're done now. Like, this match statement will return back. It will either panic or it will return back our DB, our hash map of string to string. And DB is a terrible name. Sorry about that.
Okay, so now we have some incompatible types. So DB insert is type standard option option with a string, but what is this? Expected enum standard option option found. Our arms have incompatible types in our matches.
That's interesting.
Paste the error into.
Why is my thing not like behaving?
Here. Like that. Big mess. So this is value string. So if it's a string, DB insert.
Yeah, I think the best thing
option.
Like what we want to do is just ignore, like we don't care what this match statement on line 67 returns. Mm-hmm. We're just inserting into our DB hash map and like ignoring everything else. And so I added a semicolon on line 70 that basically says, don't treat this as an expression. This is just a statement. We're doing some control flow here. Like what gets returned from here doesn't matter. We want to ignore it. And I imagine that mostly fixes our issue.
I think we need to do like okay here or something.
Exactly. Yeah, that's the last thing that needs to happen. And no semicolon, because we want to treat okay as an expression. We want to return it from the function.
I see that biting me repeatedly.
Yeah, you get used to it.
Semicolons or not. Okay, so let's run it. All right, we panicked at the not yet implemented, but we didn't get any ugly failure stuff. Do we have a database? And we have an empty kvdb file.
Cool.
That's
awesome.
Win. All right, so load keys works. So let's implement set.
Okay.
So we will want function can't type set, and that shouldn't really return anything except maybe an error, I guess.
Yeah, I imagine set will error if it can't load keys and if it can't write keys, right?
Yep.
So, but like, so you're going to want to return a result, right? It's either going to be success or be an error. And the error kind, I don't know, we can just do string or whatever. I don't know, maybe IO error. We could do standard IO results. You know, it's up to whatever we want to do. As far as what it will return, like you said, set probably doesn't return anything. So the equivalent of void in Rust is the empty tuple, just open parenthesis, close parenthesis, unit, as it's called.
And then standard, maybe IO.
Yeah. And that's totally fine what you wrote there. Another way to do that is get rid of standard IO error and change result to be IO result. Those two are just completely equivalent to each other. So it's whatever you want to do. So IO result of, and you have to give the value that IO result will return, and that's going to be tuple, empty tuple unit.
That's a fun looking operator.
Yeah.
It's the big ears operator. Okay. So if we're going to set, we need to...
I mean, presumably we want to load the keys first, right?
Yep. And that's going to return stuff.
That will...
So let's just load keys.
And if load keys fails, we just, yeah, exactly, question mark. We wanted to just say, if it fails, return the error from set.
Is our thing mutable, the hash? It is, right?
Yeah, if we want to mutate it, which we will, we're going to write into it, right? So yeah, let mute map equals load keys. And set, probably we want to take a key and a value, right?
Yep.
To the function as strings.
The parameters look in Rust. It's going to be like key string, like that. How do we do parameters? Are you there?
Yeah, just like that, except string is with a capital S. That's the only difference. And I think we had a question in the chat about standard IO result hash map. Why is the second part omitted? I think there was a question about IO result and why you omit the second part, the error part, and that's because IO result is simply an alias for result of some type T, and the error is IO result. So you don't have to put an error there. IO result always has the error type IO error. Hopefully that answered the question.
Okay, so now we've got a map and we've loaded the keys into it.
Yep. And so we probably just say, map insert key value.
Yep.
And we're done if we don't care about rewriting it out to our database. But probably we should do that.
Okay, do we care about the return type of this? This insert returns an option with... No,
yeah.
We don't care if it already exists.
Yeah. So yeah, we're just going to silently overwrite the keys that already have values, right? Yeah.
All right, then we need to write it out.
Yeah, so we should have a write database or write keys or whatever we want to call it.
Should be able to just do that IO result again.
Yeah.
Look at me learning.
Go, Brian, go. You can do it. This is great.
Yep,
cool.
And we're going to pass the map in.
Mm-hmm.
So we want, it's not mutable. It's just going to be map, hash map.
And you got to provide the key value types. So what type is the key and what type is the value of our hash map?
Oh, right. String.
Mm-hmm.
Okay.
Cool.
And then we're going to serialize the map. So we need to do value?
I think it's toString.
Oh, toString. Wait, yeah, right. Go in the other direction. toString. Pass in a value and it returns a result. Okay. toString. And here we've got map, and we're telling it that we own map and it can look at it with the ampersand. I'm speaking out loud now. And that returns a result string, and it can error, so we want one of those.
Great.
Now, do we?
Yeah, toString can fail.
Where are we assigning our... Do I need to match here? Or can I just do let?
Let string, or let JSON, or whatever you want to call it.
Yeah.
And then we just take that string and we want to open a file and write the string to that file.
Open. We should talk about constants for file names at some point in the future.
Yeah, for sure.
That mu thing equals that. Okay, and then do we still need to do the matching stuff, don't we? If it fails?
I mean, that's a good question. Like, we ensured at load keys that if the file doesn't exist, we would create it. We could do it inside of our write function, but I mean, maybe we don't have to. That's kind of I don't know. It's a good question.
Let's take a good chance here. All right, so we've got our file. Now we need to file.
And file open can error, right? So we do have to do something with the error. Probably want to, yeah, exactly, question mark it.
Right. All right. So we've got some sort of buffer.
Yeah, I think the best way to write a string to a file is to write all.
Okay. And that takes a slice, an array of bytes.
Of bytes, yeah.
So here we want, is there 2 bytes?
On string, there should be yeah, 2 bytes. What was it? I'm not sure if string can just, how string gets turned into just bytes.
Just dot bytes function.
So bytes gives us an iterator over our bytes.
Oh, we don't want that.
And we don't want that. No, instead, what we want is, I believe, is there an as bytes? Should be an as bytes. Yeah, there it is, as bytes.
As bytes.
And write all can fail as well.
Okay.
And yeah, I think the last thing we need to do is return OK unit, just to signal everything's good to go. And we don't have to write return, right? Like,
oh, you're right.
The last expression in a function is its return thing.
That?
Yeah. Does that compile?
I don't think it will. I think the language server is giving me a problem with the write all. Let's see. Let's go to the first error. Use of undeclared type or module IO. So it doesn't
Yeah.
IO.
We never said use standard IO, so you have to say standard IO, not IO. Yeah.
Good. Okay, now we're down to 2 errors. 50, function set, expected standard result, result found unit.
On line 50, yeah, because we're never, on line 52, we insert and then we do nothing. Yeah, we also have to return okay unit, yep.
Okay. Love the compiler. No method name write all for standard FS file in the current scope. Method
And
write all.
below that?
Below that is you should use standard IO write.
Yay, wow. Compiler.
I'm going to have to learn to read farther down the errors just out of habit.
Yeah.
Function is never used write keys. Okay, so on set, we're going to write keys. And then we want opt key. Wait, what's it called? Opt.key and opt.value.
Awesome.
Ooh. Accept error handling.
What do we want? I don't think we want write keys. We want set.
Set.
And I believe we're in the wrong subcommand. We're in get right now, but we want to be in set.
I knew that. Oops.
And hopefully that should do it. Oh, wait, in set, we never actually call write keys. Awesome.
All right, now we've got incompatible types in our match in main. Set returns a result, but we expected a unit.
Yeah, so that's again, we're treating the match on line 45 as an expression. So it's returning back out. Exactly, yeah, putting that semicolon says, hey, it's not an expression, it's a statement. This returns unit.
Ooh, this is scary, it compiled.
Uh-oh.
All right, so we're going to do a set instead of a get this time. And nothing blew up.
Can we look at the file and see?
File in our window here. Or ignore it. And nothing. There's nothing in our file. So let's go figure out why we suck. So in set, we load keys, we insert it, and then we write it. Talk to
one good thing, one thing that we didn't do is when we called set on line 47, if that errors, we just ignore that error, right? So we probably want to call unwrap on that or something like that to at least make sure that if there's an error, it panics. And that probably will give us more information about what's going on, what's going wrong, if we run it again.
So we got a couple warnings. Standard result must be used on 54. That's returning a result, and we're not doing anything with it.
Yeah, put the question mark there to propagate it up.
Build it again. Run it again. Now we panicked on an error, other message, bad file descriptor. So when we create the file, now when we open the file, it fails here on our right keys.
I think.
So we create the file if it doesn't exist.
We probably don't have permission on to read the file when we're calling open. Did you see what line panicked?
Thread main panicked at called result unwrap on error value. I don't see a line number. Should I run it with rust backtrace equals 1?
Yeah, that would help.
Whoa. Now we got some output. All right. So that was at trace unsynchronized, backtrace print format, blah, 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 mod rs. More backtrace, more lots of ats. Main 47.
That makes sense. Should be other stack frames.
I'm not good. KV subcommand as core format here. I'm going to paste this whole thing. And you can teach me how to read it. Okay, it's at the bottom of our doc.
All right, so you can see yeah, that's the issue, because we are propagating the issue up, and we're not. So if we were to use a library that helps us with error handling, there's usually ways to like keep track of where, like, what caused a certain error and stuff. So we're panicking at main, and that's where it's telling us. It's telling us we're panicking there, but it doesn't tell us where exactly it's coming from, which is a bit unfortunate. I mean, my thought is that we don't have write permissions. So if on line 60, I'm just going to go ahead and change this to, sorry, not this one, line 61. Change it to, whoa, what just happened?
I didn't do anything. Undo.
Uh-oh. Redo. There we go. Okay. I think that's everything. Sorry about that. I think we just had a malfunction. On 61, if we just go ahead and unwrap there,
okay,
this will probably tell us if we go ahead and run it again.
Oh. Cargo build. Bad file descriptor. Display backtrace. And do I need a you need a full path for the open or the create?
No, I believe what's happening is that we're calling file open here, and file open by default does not have write permissions, so we're not opening the file. So there's a function that takes care of all of this for us, and it's standard fs write, and it takes a path and it takes the contents, and just writes the file. So basically, it will just overwrite the entire file, which is probably what we want. So instead of doing standard fs file open, we'll do standard fs write on line 60.
Load these, though.
Yeah, not in load, in write keys.
Wrong place.
And that takes two arguments, the file path that we have there, and then also JString as bytes. And we can get rid of 61 through 63 there. And standard fs write returns back a result, an IO result of tuple. So we just want to question mark that, and we don't have to assign that variable. Nope, don't, not the, we still need to return okay there, but we don't need to assign the variable file on line 60, yeah.
All right, we're not using it anymore.
Yeah.
Okay.
And hopefully this takes care of it for us.
All right, let's see what we got. Hey, kv.db has a key and a value in it.
Yay.
That is awesome. And
amazing.
we also hit the end of our scheduled streaming time. So this is a fantastic place to wrap up. I'm going to git status this. Now the lock file, does that usually go in source control?
There are varying opinions on this. For a binary like this, I would say yes.
Okay.
Yes, the lock file should go in.
Just make sure. Whoa. Yeah, whatever. All right, so it looks like that worked.
Awesome.
Oh, look at all that gorgeous rust. And I committed all of that nasty backtrace too, whatever. Another day.
So yeah, just to wrap up real quick, one thing I saw, like you were using cargo build and then calling the binary directly. There's a shortcut for that. You can do cargo run, and it just builds and then runs the binary for you. That's a little bit more convenient than running, than building and then just having to find the binary inside of the target file. But of course, eventually, at some point, you're going to want to ship this binary around, and then of course you just build the binary and can ship the binary around.
Oh, nice. And it just takes all of the extra command line parameters and passes them through. Mm-hmm. That works beautifully.
Yep. So yeah, before we wrap up, any questions or anything like that you have?
No, I probably need to marinate in this for quite a while, but
yeah.
I can't thank you enough for walking me through all of this. I feel like I made significantly more progress in an hour and a half than I would have in days on my own.
Awesome.
This is really cool.
Well, yeah, hopefully we can do it again in the future and start looking at some more challenging stuff and some more of the nuances of Rust's ownership system and things like that. But this definitely was a good start, for sure.
Yeah, awesome. Thank you so much, Ryan. I appreciate it. Do you want to shout out your Twitter handle or YouTube account or anything so people can follow you?
Yeah, that would be awesome. So on Twitter, I'm at Ryan_Levick. At my first name _ my last name. That's definitely the best place to reach me. And I tweet incessantly about Rust. So if that's what you're into, you'll enjoy it. If not, then you might not enjoy it. I haven't been streaming lately, but I'm definitely looking to get back into it. So you can find me on YouTube as well, Ryan Levick. Search for me, and you'll find me. And I believe next week the plan is most likely to create a Redis client on my stream. So if you're interested in seeing what it looks like to actually create a Redis client library, then tune in for that. I'll be tweeting about that. And yeah, it should be fun.
Fantastic. Well, thanks again for joining me, and let's schedule the next one of these offline. I'm really excited to continue learning.
Yeah, sounds great.
Thanks, Ryan.
Yep, thanks.
Bye.
See you, everyone. Bye.